So we solve example number 2. So we are still to use the half reaction method to balance the given equation, but this time it's now taking place in a basic solution. So we are given this equation. Now the first step is for us to assign the oxidation number of each element. So we start with oxygen and then arsenic. So if that is -2, then arsenic here would be +3. And then this is 0. So oxygen on the right side is -2, making arsenic +5. And then bromine is -1. So we can see here that there is a change in the oxidation number of arsenic from +3 to +5. So there is an increase in the oxidation number, telling us that it has undergone oxidation. And for bromine, going from 0 to -1, so there is a decrease in oxidation number, telling us that it has undergone reduction. So the next step is, after assigning the oxidation numbers, so we separate the equation into two half reactions according to the change in the oxidation number. So we write here the oxidation on the left side. You don't really have to put oxidation on the left or reduction on the right. It's really up to you where you want to put it. So as long as you just write the correct half reaction. So the reduction half reaction is for bromine, so Br2. And then Br negative. And then we have here ASO3, 3 negative, AQ, and then ASO4, 3 negative, AQ. So after writing the two half reactions, next step is to balance the atoms, the number of atoms of all elements except oxygen and hydrogen. So for arsenic, there's only 1 on the left side for the oxidation half reaction and also 1 on the right, so we don't do anything to it because it's already balanced. But for bromine in the reduction half reaction, we have 2 bromine atoms on the left and there is only 1 on the right, so we are going to put a coefficient of 2 here to balance. And then next is to balance the number of oxygen atoms by adding water. So to add water, we count the number of oxygen atoms. So for oxidation, we have 3 on the left and then we have 4 on the right. So because there's only 1 oxygen on sa water, then we're going to add 1 water molecule on the left side. But for bromine here, because there is no oxygen, so we don't add water. And then the next step is to balance the number of hydrogen atoms. And to balance the number of hydrogen atoms is we count. So there are 2 hydrogen atoms here, so we're going to add the hydrogen ion on the right side, H+. AQ. So duha man to siya, so we're going to put 2 hydrogen ions on the right side. So again, for the reduction half reaction with the hydrogen involved, so we don't touch and we don't do anything to it. Next is to balance the charges. So the charge here is -3. This is 0. This is -3. What did I write? -3 and +2. So the total on the left side is -3 and the total on the right side is -1. So we add electrons. Question is, where do we add electron? On the more positive side. And which is more positive, -3 or -1? Which is greater? So the greater value is -1, and the difference between -3 and -1 is 2. So we add 2 electrons on the right side. So diba sa oxidation, kay ang electrons kay dapat naa sa right because there is a loss of electrons sa oxidation. And then here for bromine, so it's 0 on the left side and it's -2 on the right side. So 0 is more positive than -2. The difference is 2, so we're going to add 2 electrons on the left side. Next step is to make the number of electrons in both half equations equal, half reactions equal. But as you can see in this example, there are already 2 electrons on the left on the oxidation half reaction and 2 also on the reduction half reaction. So, wala na ta. Okay, equal naman ang number of electrons. So, the next step would be for us to add the two half reactions. So, let's just rewrite. So, for oxidation, it's ASO3, 3 negative, AQ, plus H2O, and then ASO4, 3 negative, AQ, plus 2H plus, AQ, plus 2 electrons. And then for bromine, so we have Br2 plus 2 electrons, and then 2Br negative, AQ. And then we add the two equations. So we cancel the number of electrons that are equal, and then we just copy the substances on the left and on the right side of the equation. So ASO3, 3 negative, AQ, plus Br2, plus H2O, okay, may kapareha sa H2O on the right side, and then ASO4, 3 negative, AQ, plus 2Br negative, AQ, plus 2H plus, AQ. So, before we check, let's go back to the given basic ang solution at which the reaction takes place. So, if it's basic, instead of H plus ang mahabilin, it should be OH. This is indicative. This is the ion nga nag-indicate siya nga basic ang solution. So, what we're going to do here is to add the equation, no? Knowing that for water, the ions nga that make up water is H plus and OH negative. So, the reaction between H plus and OH negative ion will form water. So, what we're going to do is just to cancel this. So, kung pila dapat ang hydrogen ions on one side of the equation, whichever siya ma-allocate, that's also the number of hydrogen ions nga ato ibutang on the other side of the equation. So, kay naaman ni siya, this is on the product side, so we're going to add H plus on the reactant side. But, we're going to add this equation. Kay water man, para neutral, para walay ma-change, no? Liquid. So, na 2H plus diri, and then we also have 2H plus here, makancel na siya. And then we add again. So, when we add again, copy na sa daaning ASO3, 3 negative, AQ, plus Br2, plus 2OH negative, AQ, and then ASO3, 3 negative, plus 2Br negative, plus, for water. So, as you can see, we have water here, isa, and then we have water here, duha. So, we subtract 2 minus 1, we have 1, greater ang coefficient ni water here on the right side. So, naay isa ka water nga mahabilin on the right side. So, let's try to check if our answer is balanced. So, for arsenic, we have 1 on the left, and we also have 1 on the right. Naay duha ka bromine on the left, we also have 2 bromine atoms on the left or on the right side. So, for oxygen, we have 3 plus 2, so that's a total of 5, and then okay, nakoy na sayo. Sorry, this should be ASO4. Okay, one siya ni balance. Okay, so we have 4 plus 1, that's 5. And then hydrogen is 2 plus 2, that's a total of 2 and 2, so that's equal. So the total charge here is negative 3 plus 0 and negative 2. So that's a total of negative 5. So negative 3, negative 2, and 0, that's also a total of negative 5. So this is our final answer.